I'm Thomas Grayson, and this is my final project using HBase to analyze healthcare data. The goal of this project was to use HBase to load a healthcare dataset and aggregate it to determine which states have the highest charges and payments for the most common diagnoses. The data comes from the U.S. Centers for Medicare and Medicaid Services, otherwise known as CMS. They have Medicare provider utilization and payment data for inpatients. The data comes from their Medicare inpatient prospective payment system. The Medicare made payments to 3,000 hospitals for the 100 most common diagnoses, otherwise known as the Medicare Severity Diagnosis Related Groups, or DRGs. This data is for fiscal year 2012. The data are provided in a CSV file. There's one record per DRG hospital combination. Roughly 158,000 records in all. It's 26 megabytes uncompressed. I'll quickly go over HBase. It's a column-oriented database for large, wide, sparse tables. Each row contains a key, timestamp, and one or more column families, which are a collection of columns. Each column family can contain one or more columns that are defined dynamically at runtime. This is unlike SQL databases. Rows may have many versions, which are identified by their timestamps. The data are stored in Hadoop's HDFS file system, facilitating distributed storage and the use of MapReduce jobs to process the data. Each data cell is stored as an untyped array of bytes. HBase is well suited for applications with very large tables that need large capacity and speed. It inherits the distributed storage and MapReduce processing model from Hadoop. It's highly scalable on commodity hardware and attractive to MapReduce users. It can be used as a Hadoop source or sink in MapReduce jobs. The Java API and interactive shell are typical ways of interfacing with HBase. HBase nevertheless has many drawbacks. It has very basic functionality in comparison with a relational database. There's no built-in support for joins. You either have to code them yourself or denormalize the data. There's no innate support for secondary indexes. You need to search or filter on the row key or build one's own secondary indexes. The data operations are quite rudimentary. You can get, which retrieves a row by its key. You can put, which writes a row to the database. And you can scan, which iterates through all the rows or some filtered subset. The bulk loading tools are hard to use because of the preparation involved, and Java coding is frequently required. From an ACID point of view, it has read-committed support only, and the shell has clumsy formatting and cannot export data. The challenges of this project were that bulk loading the data was a lot of work, requiring many steps. Aggregating the data to perform the equivalent of a SQL group by requires a lot of Java coding. The lack of native ability to export the data to a text file required writing Java code to generate results in that format. Quick overview of the software I used. I used one of the CentOS VMs that we originally developed for this class. I ran the VM on Windows 7. I was using the Cloud Era CDH 4.6 distribution with Hadoop and HBase. I installed the Eclipse Kepler VM, IDE in the VM. I used Java 7. I used PowerShell in Windows for some pre-processing, and OpenOffice Calc to review the results. Now I'll give a quick overview of the steps I took. I installed HBase in the Linux virtual machine. I installed the Eclipse development environment in the VM. I tested the development environment there with simple MapReduce and HBase examples. I wanted to make sure that I could debug MapReduce and HBase jobs. I downloaded the DRG data. The Each row contains average charges, average total payments, and average total Medicare payments. The average charges represent the average of the charges that a particular hospital had for that DRG. The average total payments is the average of the total payments that a hospital received for that DRG from any source: Medicare, other insurance, or direct payments from the patient. The average total Medicare payments is the average payments from Medicare only that the hospital received for that DRG. I pre-processed the CSV file in PowerShell to reformat the columns, remove the header row, and change the delimiter to a tab. I bulk loaded the dataset into HBase. I created the table DRG with 5 splits. Normally, when you load data into HBase row by row, HBase takes care of splitting it for you. But in this case, you need to anticipate the splits in advance. And then I populated the table with HBase's import TSV and load incremental HFiles tools. After that, I ran a custom MapReduce and HBase Java program, which aggregated the data and saved the results to HBase tables and a tab-separated values text file. In the first phase, the MapReduce job calculated for each DRG state combination the average of the average charges, average total payments, and average Medicare payments, so that's averages of averages, and saved them in the table DRG summary. That table had about 5,000 rows. It was not exactly 5,100 rows, which you might expect for 51 states and the District of Columbia times 100 DRGs, because some states did not have any of those DRGs. In phase 2, I iterated through the DRG summary rows. This was not a MapReduce job, but just a straight iteration through the rows. For 5,000 rows, that was efficient. For each DRG, I found the state with the maximum value for each of the 3 statistics, saved the results to the DRG max table, and also wrote them to the DRG max.csv file. This table and file had 100 rows, 1 per DRG. Then I examined the results in OpenOffice Calc in a spreadsheet and found which states appeared most frequently for each of the 3 statistics. So here's a quick look at the original CSV file of DRG data as it came from CMS after it had been loaded into OpenOffice Calc for easy viewing. You can see in the first column that the DRG definition, that the DRG code 039 is seen here, and the DRG definition name, extracranial procedures, are together in a single column. The import TSV file, program rather, can't deal with the header row, so I had to strip that out. I split the DRG column, the DRG definition column, into a code and name description column separately, and I also created a row key column, which was the combination of the DRG and the provider ID, which was a unique identifier for that row. This is just a quick look at the PowerShell script I used to process the CSV file. This is actually one big long statement with several pipelines, but it imports the file, does the parsing, and then writes it back out without the header and a tab delimiter. So after the PowerShell script has processed the file, you can see the header row is gone. The first column now contains the row key. That's the 039:010001. There's separate columns for the codes and the descriptions. Otherwise, the data is unchanged. Then there is the process of importing the data from my pre-processed text file into HBase. I created the table DRG in the HBase shell with the predefined splits as mentioned before. I copied the preprocessed data file in the HEFS. I imported the file into the CSV file into incremental files, otherwise known as H files, with the import TSV tool. Then I had to change the permissions of the files to HDFS, and then I used the load incremental files tool to to load the incremental files into HBase. So then I ran my summarizer program. In the top half you can see the start of the job, and in the bottom you can see the end, and you can also see that I listed that the DRG max file was there. You can also see that that run took 192 seconds. When you run it in the Eclipse debugger, it takes considerably less time, often 20 to 30 seconds. So we can do that quickly as a demo now. So here is the Eclipse running in the VM, and here's a shell. We'll enter the HBase shell. This usually happens a little faster. I will list the tables in the database, and we'll see that we only have the DRG table here now. We can scan DRG. We'll just take a look at the first row. And here you can see how the data looked when after it was imported. You can see the row key on the left, and then the address, average charges, and so on. Now we can come back to Eclipse, and we can run the summarizer job. This first has the map reduce phase, which is running now. When the map reduce phase completes, it creates the DRG summary table, or rather the DRG max table, and then writes the CSV file. We are still in the map reduce job now. Now it's in the second phase. It's created the DRG max table, and now it's completed. This took 43 seconds. It sometimes runs faster than that. Now if we come back to the shell, we do list here. We'll see that there's now a DRG max and DRG summary table. We take a quick look at the first row of the DRG summary table that was created in phase 1. You can see that for Alaska and that DRG 039, it averaged the average charges, the average Medicare payments, and the average total payments. We now take a look at the same for DRG max. Here it's found the max of those averages of averages for and we can see that for 039 California had the maximum for average charges. Maryland had the maximum for average Medicare payments, and Maryland again had the maximum average for average total payments. So now again, we can see that the if we looked at the results, this sort of replicates what I just did live, and you can take a look at this in the spreadsheet as well. This is the DOG CSV file. Oh, I can come back here and actually point out, if we refresh this, we now have a DOG Max file here. We can double click on that to open it up, and here's the file that we just created. So, by way of conclusion, the states with the highest average charges were New Jersey, California, and Nevada. Average total payments, Alaska, the District of Columbia, and Maryland. And for the average total Medicare payments, Alaska, Maryland, and DC. So based on these preliminary results, the cost of medical care for these common DRGs appears to be more expensive in these locations. I also found that HBase is a powerful product but challenging to use, and HBase is not for casual implementations. Thank you very much.